So just shuffle some windows here and we'll start. So now that that we have learned actually how to commit our changes, we are going to see how we can see the history of our commits and how we can actually modify the commit tree. But before we actually modify the tree, let's see how we can show the history. And you have already seen this command. Pedro has shown it as well, and I have also shown it on one occasion. So it is Git Log. And Git Log, by default, is going to list all the commits of the current branch with the most recent commit at the very top. So we see here one commit on September 2nd at 2 o'clock, and there is a parent commit just below 2 hours later, and so on. So Git Log is going to list all these different commits in order. So you may also, for example, you want to see the history of commits, but you are not interested in the most recent ones, but you want to go sometime back in time to a particular commit. Then you can use as argument the hash of the particular commit, and then Git Log is going to output that particular commit and all the parent commits starting from that particular one. If you do not have an argument, default is going to be head. And there are some other useful options that you can use with log. One particular one is -n, followed by the number, which is only going to list the n recent commits. And this is useful if you know that, okay, I only want to see the last 3 commits or last 5 commits and so on, and you don't want a long list of commits. And another useful one, which again, I mean, you have seen before that Pedro has shown, is to use the --1 line option, which is going to shorten the output of Git Log by 1 commit per line. And this is very useful because you can have a better overview of all the commits using this. So for example, here we see, as I said, 1 commit per line. We have the most recent commit at the top, which the head is also pointing to in this case. It's pointing to the master branch. So in this case, we are on the master branch. And then there are several commits, and we also have the commit message, actually the first line of the commit message in the output. And there are other options which you can look into. I will not discuss them here. You can also check the documentation later, but these are the most useful commands. Well, actually another useful command, maybe not used too much, but I find useful, is the grep option. And this allows you to search for a regular expression in the commit messages. So for example, you can write, for example, bug. And so you can search for all the commits that have the word bug in the commit message. And this is, of course, very useful if there are commits which match this regular expression. Sometimes it's not so easy to know what this regular expression should be. This is why it's also important that you give appropriate commit messages to your commits that you and your future you or your collaborators actually can make sense of, and also maybe match some of these regular expressions that you can think of. And this may be actually helpful later on to find certain commits or find certain implementations. Okay, you can also look for commits in a particular time frame. And for this, you can use the options dash after or before. The argument date can actually be specified in different ways. Here are just some examples. One can actually just type the end of May, or one can actually type the month and the date. So there are some different options one can do that. And again, I mean here, so in this particular case, it's searching for all commits between May 31st and June 15th. And in this particular case, there were two. Well, actually, the most recent and earliest in this case is given, but there may be some in between. But this is one way you can look into a certain time frame. And if you need more verbosity, there are some useful options. One of them is --name status. And what this command, well, using this option, Git Log is also going to list all the files that have been changed during the commit. And here M stands for modified, D stands for deleted, and there is another option which is A, which stands for added. So this way you may actually see which files have been changed. And this is a useful starting point if you want to look for bugs. But if you want even more information, then you can actually use the --stat option. And this provides, for example, how many lines were changed in a particular file. And if you really need to debug a code, then the way to go is probably using Git Log -b together with the reference. And this displays a lot of information. So it will list all the lines that have been changed. And yeah, so the output may be overwhelming, and it's something that you probably only want to use if you are looking for a bug in your code. Okay, so as I said, by default, Git Log is only going to list the commits which are present in the current branch. If you are working with multiple branches, and eventually, I mean, all of us will do, the option to specify is --all, which is going to display all the branches that you're having in your commit tree. And another very nice option, especially if you want to list the commits from all the branches, is to use it together with --graph, which is going to make the output look like an ASCII tree. And it's, yeah, so the tree is going to have a nice visual aspect. And together with one line, again, it makes it even more visible, because this way, I mean, you have one line per commit, and then basically you have all these ramifications whenever you are creating new branches. And another important thing is that also, I mean, Pedro mentioned, is that instead of typing this very long command for plotting the Git history, you may create an alias for this command. And Pedro has shown how to do that, and I do recommend you do it. It's very convenient. But it's, of course, if you want to type all, then no one will stop you. But it's good, and you can always change your alias if you find that it's not working for you. So that is possible. But so Git log commands so the Git log command is only going to display the change that affects the commit tree. But the Git also stores additional information in addition to these logs, and that goes into the reference log, and in short, it's called ref log. So one is the ref log updated. This gets updated every time, for example, the tip of the branch, which is the latest commit of the branch, or some other references are modified. And the way we access this history is with the Git ref log command. And one comment here, because we are going to get back to it later. So one good example when the tip of the branch is updated is, for example, if you enter a detached state, detached head node, I meant. So that's when ref log becomes important, and we are going to actually have an exercise on that. So I will come back to this. So let's understand how ref log works, and assume we are assume we want to create and later on discard a commit. So what I am going to do, and I will not type this because we are going to do the exercise shortly, but I can modify the file txt by adding some content to this file, and then I can use the Git Commit Command together with -a option, which means that it's going to add all the changes in the working directory to the staging area or the index, and then also the -m option followed by the commit message. And I should comment here, but probably you know already, I mean, if you do not type the -m option and the message, then you're going to be prompted with an editor where you should start typing your message. And then that may be useful if you want to write more than one line in the commit message. You want, well, to have a good explanation of the changes that you implemented in your code. So that can be useful sometimes. But otherwise, if you only want to have a commit message of one line, then the -m option is useful. So after I do this commit, I can inspect the history using the git log --one line. And then what I am going to see in this particular case is two commits, a first commit, this hash, and then the latest one, which the head is pointing on the master branch. I'm going to, with the message, I'm going to delete this. Now let's assume that we realize that, okay, this is a change that we did not want to do. Then we can simply remove this commit, and the way we do that is using the Git Reset command. Or one way to do that is using the Git Reset command. And what the command does actually is going to use the option hard, which means that sorry, first I should explain the reference. So the argument is the reference that we want to reset to, and in this case is head tilde, which means the commit which was the previous commit on this branch compared to head. So just in this case, the commit 23b3. And it's of course also possible to refer to this commit by its hash sum instead of using the head tilde. Okay, but there are several options that one can use with reset, and one of them is --hard. We are going to go to other options later, but what this means is remove all changes from the working directory, also clear the index, and then of course the head is going to be moved to this hash sum. If we inspect the history again after using the Git Reset command, then we can see that basically the commit we had before has disappeared from the history, and now the head points to the head points to this commit here, which was the very first commit. So the second commit, the one that we have deleted, disappeared from the log, but we can still reference to it from the reference log. So and the way we access the reference log again is by using the command git ref log. And here, well, the output is going to provide us basically a list of all the commands that we have used that changed the head. So in the previous example, we have actually used git together with reset that moved the head from the let's see, from yes, we have moved the head from 2F5 to this hash here. So at the left, it's always going to be the hash corresponding to the commit after the command has been used. Hope this makes sense. Otherwise, please write and I'll explain better. So at this point, I mean, we have gone back to the initial commit. We could attempt to recover the commit that we discarded using git reset. And we can do that by, again, using git reset or switching back to our branch or using checkout. And we'll have more examples on this later. And before, yeah, we'll have some exercise time a bit later, but let's go into a bit more material first. So let's see how we can actually compare commits. So up to now, we've only seen how we can investigate history, but how we can actually compare what is in different commits. So one good way to do that is using git diff. And so before you have learned to use git diff with files as arguments, but if you actually specify the hashes of different commits, you can check all the files that have been changed in these two commits here. And well, in this example, it's just one additional line that has been added, and that is more content. But of course, I mean, this can be the output can be very long depending on how many changes you have implemented. So if you have many files that have been changed, this has not been the case here, but if you have many files, then of course it would be helpful if you can look into the changes of individual files. And the way we can do that is by adding the -- option with the file that you want to look into as argument. So we still have git diff together with the hash sums of the two commits that we want to compare, and the addition of this option and argument. And in this case, because we only changed one file, we are going to get the same output. So it's not a most exciting example, but it shows you at least how the command should be used or can be used. So you've already seen this, but I've included it because it's git diff is one of the most important commands, and I think one can never show it enough times. So depending on the options that you use together with git diff, and also on the arguments that you use with git, you get different outputs. So if git diff is used together with head, then it's going to list all the uncommitted changes, all modifications that you have compared to the head, so the very latest commit. If you want, for example, to only show the changes with changes between the working directory and the index, or the staging area, then you should use the git diff command, just as it is. And then if you want to list all the changes, all the state changes, then you should add the option -- cached. So all this, so what staged changes means is all changes between the index or the staging area and the previous commit or the head. And I should remark here that -- cached is works exactly the same as -- staged. So in some cases you may see the other one, but the output is exactly the same. So git diff -- cached is equivalent to git diff -- staged. So okay, let's see how we can navigate the commit tree, and actually better say how we can refer to different commits in the commit tree. So in order to use commits, it's well, useful if we can navigate through the tree. And we had one short example before when we used Git Reset. We can also use Git Checkout to navigate through the tree. And these commands, although they are similar in some way, they do behave a little bit differently. So I'm going to show some examples on both. So let's, well, I should say, whenever you want to use Git Checkout and Git Reset, it's a good idea that you print the history first, or list the history first. So always do Git Log with your preferred options when you want to navigate the tree. So Git Log, in this case, with -- grep and one line. So it gives this nice ASCII plot of the tree structure. And we see that, well, in this case, again, the head is pointing to the tip of the branch. And again, I mean, tip of the branch is actually the latest commit of the branch, and in this case, the master branch. And we may move from this commit that head is pointing to let's say this commit, previous commit on the master branch. So you may see there are other commits, but they are on the second branch. What we will do is actually check out two-way commit on the same branch, but a previous one. And the way we can do that is to use Git Checkout and the hash of that particular commit. And then once we type this, then we are going to get an output that, okay, now the head has been changed to a different pointer or hash, and it also writes the commit message of that particular commit that the head has moved to. And if we show Git Log again, then we see that we are no longer, well, the previous commit that we had is no longer in our history, and we only have the commits that precede the one that we checked out to. So maybe you wonder here why the second branch has been listed in the command when we used the command before, and why is no longer the case here. So in the previous case, the commit F0 had two parents, one which was on the master branch and a parent which was on the second branch. And then Git Log is going to show both of the parents. But now, because we have moved to this commit D3, we only have parents basically on the master branch, and that is why we only have this additional commit in the list. I hope this makes sense to you. So so Git Checkout only moves the head. The tip of the branch is not modified, And how, yes, and one, so Git Checkout is going to attempt to give the local modifications to the files in the working tree, but my recommendation is that if you do want to use Git Checkout or Git Reset, you should be working with a clean a working tree, and we will learn soon how we can actually achieve that. Because again, I mean, as it also says here, it attempts to keep the local modifications, but sometimes there are conflicts, and again, it's better to have a clean working tree. So skip this because I talked about the detached head, but so whenever you check out from the head which was on the tip of the branch, you do get a detached head, and then Git is actually going to give you a long warning that okay, now you are in a Git detached head. Basically, you are no longer on any branch, and well, we will learn how to tackle that. But if you do want to get rid of this message, then you can include this setting in your configuration file, which is basically going to get rid of the warning. As a beginner, well, if you're still a beginner, I would say that it's better to keep it because it makes it clearer if you are in a detached head mode or not. But let's say that you decided to use this configuration option and then you realize, oh, I actually do not know anymore. Am I in a detached head state or not? There are actually commands that you can use in order to check that. And actually, you can see this in several ways. Maybe the easiest one is by using Git Log. So that is going to show you the history. And then if I specify -n1, then I am only going to see the very latest commit. So basically where the head is. And in this case, the head is pointing to the master. So then I know that I'm actually at the tip of the master branch. Other ways are to either use the git ref parse command with these options, which actually I don't know by heart. I always have to look them up, but this is one way of doing it with the argument head, and then it's going to give as output the reference of head. And if that is master, that means that, okay, head is at the tip of the master branch. And an alternative way we have also seen in lecture 2 is to actually just cut the head file, which is in the hidden Git directory. And then this as well will reference the master branch if we are actually on the tip of the master branch. If we are not, so if we are in a detached head mode, then these commands are going to output a commit instead. So it's not going to bring the reference of a branch. So it will only show the commit. And also here, I mean, head. So the git ref parse command is going to output just head if we are in detached mode, but not actually a reference to a branch. Simply because in detached head mode, we are not on a branch anymore. Okay, so a few more slides before exercise time. So let's say that you did git checkout to a commit, to another to some commit, and you realize that you actually do not want to be in this detached head state. Then the way to get back is just to type git checkout master. This is going to simply get to the tip of the master branch. And this is very convenient if you realize, oh, I actually, well, you may use git checkout to get to a certain commit. Maybe you want to inspect the files, the state of the files in that particular commit, but then you can simply get back to the master branch, the tip of the master branch using git checkout master. And some more options with Git Reset. So again, Git Reset works similarly to Git Checkout, but I prefer to use Git Reset simply because there are more options with it, which makes it very clear what is changed in the working directory and the index when we actually use the Git Reset. And by default, the option is -- mixed, which means that the head is going to be updated, and also the index is going to be cleared. So if you had any staged modifications, those are going to be cleared when you use Git Reset. Together with the soft option, then Git is going to try to keep the changes, the modifications that you had in the working tree, and it's also going to keep the modifications in the staging area or the index. If you realize you've done big mistakes you do not want to keep, most often you want to use it together with the -- hard option, which means that you are going to ignore all modifications that you have done in the working tree and all modifications that you have staged already. So this is like a harsh option with Git Reset, but it's useful sometimes. So we have seen how we can actually use Git Checkout with hash, commit hash, but we can also use it with files as arguments, and Pedro has also shown this in the previous lecture. So if we have the file name as argument, then Git Checkout is going to disregard all the files that all the changes that have been made to that file. And while Git Reset is actually going to unstage the modifications, but it is going to keep the changes that were in the working directory. So it only unstages the modifications from the staging area. So for example, one can edit the file txt by appending some content to it, and we can stage this file. If we use the version git diff, the command git diff together with the -- cached option, then we are going to show all the changes that have been staged compared to the previous commit. And in this case, it's just this additional line, even more content. So these are the staged modifications. Now, if I do git reset file txt, then I'm going to unstage these modifications. So I will only have them in the working directory. And so git diff cached is going to give me no output, because basically there are no staged changes compared to the head, because we have not the file txt, the changes in the file txt are no longer staged. If we type git diff, this is going to show us the differences between the working directory and the staging area or the index. And in this case, there is a difference, and then it is this addition that we have done to the file txt. And here comes the important difference with the Git Checkout command. So if we use Git Checkout together with the argument file, then I am not only going to unstage the file, but I am also going to remove the modifications that are in the working directory. And this is actually what this means: updated one path from the index. yes, update one path from the index. So the index is changed, and git diff shows basically no difference between, or it outputs no difference between the working directory and the staging area. So we basically lost the modifications that we have made to the file txt by using Git Checkout. And this has taken quite some time. So we are going to take a break now and do some exercises. We will do exercises 1 and 2, and I will show you where you where you can find those. So again, they are in scripts, right? Yes. And then in the directory 4, and it's numbered into, with respect to the lecture. And you are going to find several exercises there, but at this point, I would like you to do number 1 and 2. And if you click on this one, you actually see the README, which is also shown on this GitHub page in a more readable format. And the goal of this exercise basically is to investigate the history, and you have all the steps that you should do here. I will not read them loud. And let's aim for, I actually think that you do not need more than 10 minutes for this, but I'm going to let you work on your own for 6 minutes, and then I'm going to also show on the screen how you can solve this in the final ones. So yeah, let's give it until 5 past 11. Okay, I realized you didn't have too much time to finish it, but I think it may be useful for some of you to see how this exercise can be solved. And well, you can just decrease the volume if you prefer to work on the exercise on your own. So I am going to start with exercise 1. So I am now in this directory for commits, which is in the intro Git, or you may have course intro Git directory and then scripts. So let's move to the first one. And on the wrong one, I think. Yes, sorry. I have saved it. Apologies for that. So exercise 1. Yes, this is good. This has the repository. Okay, so I am going to go into the repository for this exercise, and so the goal of this exercise was just to learn how to use the Git Log command. And the first question here is investigate history and how many commits does the main branch contain. And in order to see the history, I am going to type Git Log and some further options, 1 line. And I'm going to add all, because I am interested to see if actually this repository has several branches or not. And I'm also going to add Grep so that the output is a bit nicer. And I could, well, I do have an alias defined for this, but I will write the whole command in case you do not have the alias. So I see that actually I have a main branch, which is called master in my case. And I have 2 additional branches, experiment and new direction. And the question was actually how to see how many commits main has. So I'm going to remove this all option here so that I can only focus on the main branch, the master one which the head is pointing to as well. So then I see that I have, well, 5. Did I count right? Yes, 5 commands in this main branch. And then as a second option was how to make the output cleaner. Actually, I have already done that using these options. If I were to only write Git log, then I would get more information, a long hash, additional references for this particular commit, if there are, and in this case, yes, head points to the tip of the master, and I have information on the committer, the date, and the commit message. Okay, and then I can also see how many commits there are that contain the word abandon in the commit message. And in order to do that, I'm going to use this grep option together with git log. So git log -- grep, and then some expression. I am going to use abandon, as that's what the exercise inquires about. And I do find this commit from November 10th that has the word abandon in this in the commit message. And then the final question is regarding the reference log. So how do I access the reference log? Instead of typing git log, I actually type git ref log. And I can see that, yeah, so this is one way of referencing, one way of listing all the commits that have been made on the local machine. Maybe actually I should mention now that ref log is only on the local machine. So if you are pushing your repository to GitHub, then only the commit tree is going to be pushed. So there will be no reference to the commits that you do behind the scenes on your local machine. And yeah, that's about it. So if I want to see where the head was 6 steps back, then I should actually check the head and then followed by this index 6. Okay. Then I'm going to move to the second exercise, which deals with detached heads. I'm going to quickly open here a window with the exercise. Yeah, so this exercise is about recovering the head, and the goal is to identify when we get into a detached head mode and how we can actually recover from this. And I'm going to first check the history, and I will use one line again. And I will also use graph and all, because I have actually, it's the first time, well, it's not the first time in this case that I am looking to this repository, but it may be the first time I look at this, and then I do want to have a nice overview over all branches and commits that are there. And then I see actually that this particular repository only has one branch, the master branch. But you may see already here that the head is not pointing to the tip of the master branch. So this means that the head is actually in a detached head situation. And I can also see that by using the commands we learned before. So I can either do git log with the options -n one, so the very last commit, and then I see that actually this commit does not point to the tip of the head, to the tip of the branch, which means I'm in a detached head situation. And alternatively, I can also use Git Rev, or I can cut the Git head, but for sake of time, I am not going to show those. You have them in the lesson material as well. And then the second point of the exercise is to return the head back to the tip of the branch. And there is a very easy solution for this. One can just check out to master. And yes, and then just by typing master, I'm actually going to get the tip of the branch master. So now I am switched back to master. Again, in detached head mode, then we are actually not on any branch. So that's why it's specified that it has switched to a new branch. And I can use the same commands as before to actually see which where the head points to, and in this case it does point to master, the tip of the master branch. Okay then, and as we are actually running out of time quite quickly, I am going to continue with the next part of the lecture. If there are questions, please write them, and I or my colleagues are going to answer that. So let's move this away. Okay, and now we are actually getting to tagging. We learned a little bit about tags before. We can list all the tags that are defined for a commit tree by using the Git Tag command, and I can also search for a tag by specifying -l and some string or expression that I want to look for. And in the easiest case, I can define a tag by simply typing Git tag and the tag name. And so what Git is going to do is going to create a tag that points to the current head, and it's going to add this additional reference to the commit. And well, this can be, for example, something which tracks the version number, so it can be v1.2, or it can be anything that you find useful. And usually you do want to add tags to versions that maybe you want to release to other persons, or something that has been well tested and documented that you want to easily refer to. And you can also create annotated tags by adding that A and additional comments to the tag. And this way you can store extra information like who has created the tag and the creation time and any additional comments for this particular tag. So how can we refer to commit? So up to now we refer to commit by either specifying head or specifying master, specifying commit IDs, which may not be so convenient as the strings are not so easy to read. But we can also now specify it with respect to the tag that we have defined. So if you remember before, we have actually defined the tag which is called first. We can also use long names. It's also common, but instead of specifying master, you can actually write reps, heads, master, and so on, which is maybe actually unnecessary, as master is pointing to this. But in some cases you need a long path. So we can also refer to ancestors of a commit. And what are the ancestors of a commit? They are basically the parents of a commit on the same branch. So in this example here, so first you can see the history of this particular commit or this particular repository, and then you may use Git together with the rev parse and the commit as argument, in this case the head, the latest release, and this is going to output you a shortened hash for this commit. And shortened because we actually use this option --short here. By adding a tilde to head, I am going to refer to the commit previously to head. And in this particular case is D3 C6. And then again, I mean, tilde refers to commits which are on the same branch. So this is something you should keep in mind. So I actually have to follow the line of commits on this main branch and not some other commits which may be in between, but yes. And then similarly, if I add 2 tildes, then I am going to get to a commit 2 steps back in time compared to the head one, again on the same branch. And these are some equivalent notations that you can use together with references. So instead of specifying, for example, reference tilde tilde, you can actually use reference tilde too. And then, as I said, well, maybe I didn't say, but it was understood that tilde, so reference tilde is always going to follow the first parent. So the commits on the branch that we are on, and it's not going to refer to other parents that the commit may have. And this is actually where we are going to now. So we may be in the situation. So actually in this situation, the head has actually points to a commit that is the result of merging 2 branches, the master branch and this second branch. And we can refer to the parents of this commit by using the reference head hat 1 and head hat 2. So you see head hat 1, sorry, it's also easy to say, it's actually this parent here, which is on the main branch, which is the first branch, so to say. And the reference head 2 is this previous commit, so the parent on the second branch. And this may be a bit confusing because actually it is different to how the references for ancestors work. And again, I mean, for the first parent, so the parent which is on the same branch that we are on, then reference head and the reference tilde is equivalent, but that no longer stays true for the second parent. So actually, so this refers to the second parent of a commit, while this refers to the second commit on the first branch. Yes, second previous commit on the first branch. So I hope I made it clear enough for you. Okay, so how can we clean the work tree? I'm going to go rather fast through this because we have seen these options before. It's Git Reset always comes to the rescue. It can be used with soft or if we use that, so if we use it with soft, then it's not going to clean the tree. It's going to keep it intact. The working tree is going to be kept intact. The same for the index. While if we use it with the hard option, this is going to remove all modifications from the working tree. It's also going to unstage all modifications from the index. So we can clear unstaged files by using Git Clean, and there are many different options. One important one is dry run, which actually is going to list what Git Clean is going to clean. That means remove when, so it's going to remove the changes when used with other options. So, for example, it's always a good idea to actually use Git Clean together with dry run. The options that you want to use eventually, first get a list of the files that are going to be cleaned, and then use Git Clean without dry one, but the tested options. This way you have full control over what Git is going to clean for you. So stashing changes. So let's imagine that we are in a situation when we temporarily want to store the changes that we have in the working tree, but we are not yet ready to commit them. And this may happen, for example, if you want to do a Git Checkout and Git Reset, so you want to move the head to a different commit. Maybe you want to investigate what are the files that you had, or the changes that you have done in a particular commit. Then you are going to move the head, and it may not always be possible to restore the working tree. And why is that? Because simply there may be conflicts between the files that you have or the modifications you have in your working tree and the files that are in that particular commit. So always the best idea when you use Git Checkout and Git Reset is together with a commit as argument is to store the modifications in your working directory to the stash. And this is what we are going to learn how to do. And then this way you are going to have a clean working tree, which you can then navigate, and then you can navigate in the working you can navigate in the commit tree as required. So let's assume we try to move the head to another commit. We do this with Git Checkout, as we saw before, and actually, if we have uncommitted changes in the working directory, Git is going to complain and say that before you actually check out to a new commit, you should either commit your changes or you should stash them. And then the way as we said, maybe we are not ready to commit, then the alternative is to use Git Stash, and it has a very simple. The command is very simple, so it's just Git Stash, and what it's going to do, it's going to save the working directory, so all files in the working directory, and it's also going to save the staged changes by default in a different directory, which we will learn how to refer to. And then once we have stashed, then our working directory is all clean. The staging area is cleaned by default again. and then we can safely check out to a particular commit. And how do we access this stash directory? So first of all, we want to print all these working directories which we have saved. In this particular case, there are four, because it starts from 0, 4 stashed directories, and 0 is always the latest one. And it's also the default one when we use it with the Git Stash command. So latest one is actually this one. You may have recognized the message used, which is actually the commit message of this particular commit that the head was pointing to when we used the command. So it was here. It prints out also the hash of the head and the commit of that particular, and the message of that particular commit. So recent one, always on top. And as I said, we had a name of the branch. You see it here. There are several different branches. In this particular case, we see the matching commit message and the hash of the commit. So if we do not want, if we want more information on a particular stash, then we can use the command git stash together with show and the index of the stash, which we get by typing git stash list. So it's this index here. And in this particular case, what has been changed was actually the README file. If we want more information, more verbosity, we can add this -p option together with stash show. Then we can also see actually the lines that have been changed. So how can we recover these saved changes? We do that by using git stash pop. And that is simply going to update all these modifications in our working directory and index if appropriate. So the stash changes are then applied to the working tree, and this entry is dropped. I should add that this entry is dropped by default. So what does the entries drop mean? It simply is going to remove this listing here from the wherever stash saves the files, and it's also going to remove the files there. But there is an option that we can use together with stash so that this entry is kept, and also the files are kept in case we did a mistake and we may want actually to refer to these files again. So Git Stash is going to stash files that are already added to the index. If we do not want to stash the files which are in the index, then so in the case we only want to stash the changes which are in the working directory, then we should use this keep index option together with Git Stash. And in this way, I mean, we can use this use stash together with commits in order to gradually add commits to our directory. So let me actually give an example of what I have in mind. So for example, you have spent several days coding and you are ready to commit your changes, but actually you do not want to commit all the changes that you have done in one commit. And why you would not want to do that? Maybe they are many different implementations which you're not sure if they would work together and if the code would run properly. And then it's actually better if you commit in parts and then you compile and you test your code and then you accept the implementations gradually. So yes, so one should do is actually stage changes that should go to the commit. The stages that, the modifications that you are not ready to commit yet, then you should stash them away, but keep the index, because actually this already contains, in this case, modifications you want to commit. And then you should compile and test your code. If everything works as it should, then you can pop stash, so bring files back from the stash into your working directory, and then you can move to the next commit. Otherwise, actually, you should repeat the cycle from step 1. So we should have actually a short exercise now, exercise number 3 in. Let me bring it back. So, yes, exercise number 3 in our exercise directory. So that should be under scripts, 4 commits, and then 3 stash. So what you should try to do is to stash uncommitted changes. And let's see, should we have maybe I think that actually I'm going to show you how to do this instead, to save some time, and then we can have more time for the final exercises on their own. So I am going to bring back my terminal as soon as I find it. Okay. Move this away. Yes, I do need to read as well. So let's see. I was in exercise 2. So I will move to 3 now, which is called free stash, and I already know, I mean, I have a repository there. I'm going to go into that repository. So let's see, the goal of this exercise is to learn to check out a different commit and stash uncommitted changes if necessary. And the steps one should do is first identify the first commit. Okay, so then actually always a good idea to do Git log and see what this repository is all about. So Git log 1 line, and we'll use the graph option. I will do all at first, but okay, in this particular case, it is 1 branch only. So I can then see that the very first commit of this repository is this one, df, which has the commit message. This is going to be a cake recipe. So this already tells you a little bit about what this repository is about. And then the second step is to try to check out the commit in order to identify the initial title of the recipe. So I would say it's always good to do Git status. So if you do not know what the files of your repository are in, then do Git status. And one can not use it too many times, in my opinion. So what I can see is I'm on branch master. Of course, this I knew already from using the Git log for the history. But what this also tells me that there are no changes for the commit. So the index is basically clean in this case. But I do have modifications in my working directory. So the recipe txt has some modifications which are different compared to the previous commit. And then Well, actually, I do want to, I should investigate what the recipe in the first commit was, but I do not want to lose these modifications in my recipe. So then what I'm going to do is to stash these changes. And I do that using Git Stash, as we have just learned, and enter. And then it says that, okay, I have saved your working directory and the index. Well, in this case, it was empty, but anyway, by default, it saved the index as well. And if I do Git Stash followed by list, I can see the stash index for this particular stash, which is 0. Always 0 is the latest one. So, and now I can do Git status again just to check. And I see actually my working directory is clean. And there is nothing to commit either. So the index is also clean. Okay, so then I can happily do Git checkout and go to the first commit. And I'm going to simply copy the hash of this commit. I could alternatively use had tilde, let's see, 1, 2, 3. But I think it's safer to actually use the hash. Okay, so now I have switched to this commit, and I am in a detached head state. So I am actually no longer on the master branch. I am on no named branch actually. And what I should do is actually to find the answer what the recipe is about. And for that, I'm just going to open an editor and check the recipe file, and actually I find out that it's about my fancy cake. Okay, and then once I actually check the files, and of course in a realistic repository you may actually want to check several files. But this is just an illustrative example, and then what I'm going to do next is step 3 to restore the head and pop the changes from the stash. So how do I restore the head? I can do that simply by Git Checkout master. So that's very easy. And then so now I should actually check where I am now. I can do that using Git Log -n1, or I can type the entire log if I want. If I just do that, I see that the head is actually pointing to the tip of the master branch, as we were before doing the checkout. So then this is all good. I am going to type Git status again and see what the status of my files are. Of course, I mean, as expected, there is nothing to commit. The working tree is clean. But now I remember that actually there were changes in my recipe that I wanted to keep. And then the way I do that, so I can bring them back in the working directory by using Git Stash pop. But let's assume that I actually do not remember which ones they were, and then I can so which stash index I should refer to, and then I can actually do stash, too much status, stash, let's see, sorry for that, Git stash list. And I see that the stash that I have saved when I was when the head was pointing on this commit, the one that we are now on, as well, it has the index 0. So then I'm going to bring back those changes, Git stash pop, and then I see that again I have this modified recipe txt compared to the head. So I'm actually going to open it and see. Okay, so actually I would have lost all these different all this content if I had not stashed my modifications before doing the checkout. So how do I check that the stash is empty? I just do git stash list. And then one can see this is empty. Of course, if I had previous stashes saved, then only this particular one, 0 would have been removed. Okay, so let's. So now we have 50 minutes left. We are going to jump back to the lecture. And so making changes to the commit tree. And this is going to be actually quite fast, but I hope that we can have some time for exercises on your own. So whenever we are in a detached head mode, there is actually a big warning, and I think that using Git Checkout and Reset should be really used with caution. But this is a good additional reason to introduce you to these commands, so that you know how you can save your repository in case you need to. So what we are going to learn now is how you can actually discard the latest commit. And if you're not in a detached head mode, then discarding the latest commit is actually very easy. You just need to type git reset head and tilde, and that is going to get you to the commit, which was just previous to head. And by default, as I also mentioned before, Git Reset has the default option mixed, which means that the state of the working tree is actually kept, but the index is cleared. So we may still recover the commit if we know the hash sum, and this is why it's also very good whenever you do Git Reset or Git Checkout, you should list your history so that you can have a reference of your commits. Otherwise, of course, you can do a Git Ref log, and then you can find out the commits of your so-called lost commits there, of the commits which are no longer in the commit tree, I should say, and then so you may recover the commit, and then again, if you want to reset to the previous commit and also disregard all changes in the working directory, then you should use the --hard option. And this is not only going to clear the staging area, it's also going to clear the working tree. So then once you use these options, you are going to get a clean working tree. So what if you have committed your changes and then you realize you have actually made a mistake? So that commit is it doesn't make sense. It's wrong. Then there is a very easy fix to this situation. The first step is to stage whatever changes you forgot to include, or what the fixes of your files in this case. So I added the file and then I add it to the staging area using Git Tag. Always go to Git to use Git Status, and then I can see that I actually have changes to be committed, as I have actually added the file to the staging area. The next thing I could do is actually to use commit together with the amend option, which means that the current commit is going to be replaced by a new commit, which implements these changes that I have just done. And I should remark here that Git Commit Amend does change the hash of this commit. And the way we can understand is that it's because simply, well, if we remember from the second lecture, the commit points to the tree, it points to the author, and the committer, it points to, well, to a commit message, but also to the time when the commit was made. And because when we change files, we change the tree, we change the timestamp of our commit, then obviously this commit object is going to change and we are going to get a new hash. Thus, yeah, the commit is going to have a new hash. So this is important to remember. And I will not go through this as it's more advanced and not really super important. One thing which is good to know is how one can revert a commit. Let's say you did the quick test, you committed something, but then you realize, oh, maybe that is not a wonderful change, and I would like to undo this change. And of course, so we have already seen that you can do this using Git Reset head tilde, but actually if you are sharing your repository with others, if you have already pushed your changes to this remote repository, then you don't want to use Git Reset, because this is going to change your history, and it's very bad practice to do this when you are working with others. And then, as I said, you pushed it already to the remote. And the solution is to undo this change, so to do a new commit which undoes this change. And the advantage is that the commit tree is not modified. Well, you are going to have a new commit, but the history of the commit tree is not modified, and then it doesn't affect other people. Maybe someone else has already cloned your repository, or fetched the previous commit, and it would be bad if you simply remove that commit from the history. So quick example here. So I do a modifications in file.txt. I stage and commit these modifications, and then I get so this new commit that the head is pointing to with a explicit or a representative commit message for this teaching purpose, bad commit. And then, so as I said, we discovered that actually we need to mistake, we should report it because the implementation was very bad. Then what we can do is simply to use Git Revert and the hash. And what we can see, we still have this bad commit in our history. But in addition, we have a new commit that the head is pointing to, which simply reverted all the changes in the bad commit. So basically, this commit the head points to an F0 are going to have the same files. Okay, then. One can inspect this commit further. And Git shows all the modifications that were new in that particular commit. So we have gone through that, so I will not show that. We are now back to exercise time, and there are actually a couple of exercises left, but they are not so difficult, in my opinion. Of course, I mean, it's all relative. We all think that some well, some things which may be easy for me are harder for you and the other way around. So we have done 1, 2, 3. And it would be nice actually if you can start doing 4 to 6 and maybe do 7 later on. It would be, I think, good if you try to do this on your own, and maybe if we can stay 10 minutes longer today, and then I can show you some quick solutions for these exercises. So how would you prefer? Because I think it's good if you actually get to try it on your own than me just showing you how to do it. So I see no responses, which means that you either are too tired or you need a break, or you're very focused on the exercises. But if you prefer to work on the exercise on your own, you can just decrease the volume, as I said before, and I'm going to start showing some quick solutions. But before I do that, I would like to show the difference again between Git Revert and Reset, as I did go a bit fast there. So we had started from this commit tree with this 46 commit as the latest, and then we realized that okay, or we assume that this is a bad commit, and we wanted to revert it. If I had used reset, let's start with that, as that's what we discussed mostly. If I had used git reset and had tilde or git reset and the name of this commit, which is the previous one, then what Git would have done is to completely remove this commit from the history. And this is not a good solution when you are sharing your repository with others, because simply, I mean, they may have some changes which are based on this commit. So the solution is to use another command that keeps this history or commit tree intact, but what it does, it adds a commit which just undoes the changes. So it's going to be a new commit to 46 and so on, but the working, the files are just going to be the same as this commit here. So just undoes everything what the commit 46 did. And the command for that is git revert, and the commit that the commit, the hash of the commit, and then one can see that I still have this bad commit. Oh, what's happening? I still have the. I must have pressed some keys. I still keep this bad commit, but I'm going to have an additional one in the history. So, but then all changes all files are the ones that correspond to this previous commit as well. So hopefully this makes more sense. And I'm going to go now to the exercises. And I will start with exercise number 4, which is about discarding the latest commit. And I let's see, move to the directory for discard and repository. And the very first thing is I'm going to check the history of this repository, and I'm going to use Git Log for that, together with one line, graph, and all. So I have one branch with several commits. Head is pointing to the tip of the branch, and And I am also going to do Git status just to check if I have any unchanged or uncommitted modifications in my working directory. No, I do not have that. Everything is clean. Then I can safely disregard this latest commit. And the way I do that is using Git Reset, and then the hash that the commit that I want to reset to, but I can also use a reference. And then for the previous one, I should have head tilde. So then, so this is going to get me to the previous commit, which is 3873. So optionally, I can either you write git reset head tilde, or of course I can also use this hash, whatever is more convenient for you. And then what I can see is that I have some changes in the recipe. And let's see. There were some unstaged changes after reset. So if I want to let's see, Git Log. There were some changes in this recipe. So if I want to disregard all the changes in the working tree, it's not enough just using Git reset. I have to add the hard option here. So I can see that the head is now at this previous commit, and I am supposed to check if the recipe no longer contains the section under ideas and hints. And yes, I can confirm that by checking this file. And what I can do in the following is to try to restore the disregarded commit. And actually, the way I can do that is by using reflog, or I can simply git restore this this hash as I have it before. Otherwise, I can just type git reflog, and then that is going to give me the commit that that hand was pointing to before using git reset. So then I do git reset again, and this commit here. So how does the history tree looks like? So now I'm back at the tip of the master branch. Okay, so that was exercise number 4, and we can now move to exercise 5, which is actually even easier. So how to amend a commit, and I just need to open the GitHub page. So the goal is to learn how to amend this latest commit, and the first task is to add 2 eggs to the ingredients list. So again, I will just do git status, see all clean. I am going to, yes, edit the ingredients. Oh, it's not ingredients, it's recipe. And so I should add 2 eggs. Let's put them here. 2 eggs. Okay. And I should stage this. So I'm going to stage this at git add recipe. And yes. And now, because I actually do not want to create a new commit for this, instead of using the command git commit and the message, I am going to use the option amend, and this is going to actually, before I do that, let's do git log 1 line again. I see that I have 3 commits here. Latest one is AA. And simply I want to replace this commit with a new commit that has an updated recipe. And I then just git commit amend. And then I am prompted with the editor to type the message. I'm just going to keep it. Maybe I'm going to change this. Updated. Okay then, and if I show the git log again, I see that I still have 3 commits, but the latest commit has been updated, both in terms of hash sum and, well, obviously also the commit message has been changed and the committer. Okay, and then validate the operation. So git log should show these 3 commits. Yes, we have already seen that. We can do one additional thing if we want to show more regarding the commit, and that is using the git show command. So I can do git show and the hash, or I could just type git show had if I prefer. And then I see all the changes that this commit has implemented. And actually, when we did the amend, we added this. But this doesn't show because it is only going to compare it with respect to the previous commit. Okay, and then we have one final exercise, which I'm going to show, and that is using Revert. And that is exercise number 6. So I'm going to have a look at the history of the repository again. This is always good practice. If it's probably the first thing to do if you know nothing about the repository. So brief log with preferred options. And I see I have a master branch with possibly only one, with several commits. And this is also a baking recipe. And what I'm being asked is actually to revert this latest commit. Maybe this was not a great idea. Actually, we can check what this is. Yeah, maybe we added something which was not so interesting. I can actually use git show again in order to see what was changed in this latest commit compared to the other one. So I see that what I had included was other ideas and hints. So I added some instant coffee. Maybe I actually don't want instant coffee with this recipe, so I want to revert this change. And then I do that by typing git revert and then the hash of the commit that I want to revert from. And then I'm going to keep the message the same. And then if I do git log again, then I see that I still have this old commit, other ideas and hints, but I have an additional commit which simply reverted those changes, and I can inspect the recipe and I can confirm that actually I no longer have this section other ideas and hints that was present in the previous commit. So that's about it actually for this exercise as well. And I would like to say that if you have time later today or later next week, the exercise number 7, the workflow, is really a great exercise which ties together several commits that we have learned actually these days. And yeah, I can only recommend that that you do it. And if you have questions either about the exercise or anything about the material, please write them. I'm just trying to catch up with the answers in the Q&A document, but if you have new questions, please just post them at any time, and maybe even if it takes a bit of time to answer them, we will get to them. And actually both Pedro and Birgitte were wonderful at answering those questions. So let's